The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones, usually starting with 0 and 1. The sequence typically starts like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. Understanding the Fibonacci sequence can be defined recursively as follows: 0, 0, phone 1, phone 1 to form one recursive implementation in Python to compute Fibonacci numbers using recursion in Python. We can define a function that calls itself to calculate the previous two Fibonacci numbers until it reaches the base cases 0 or 1. Here's how you can implement the Fibonacci sequence using recursion in Python. Python def a Fibonacci base case the first two Fibonacci numbers. If 0, return 0, if 1, return 1, else recursive case sum of the two preceding numbers, return Fibonacci 1, Fibonacci 2. Example usage: change this number to compute a different Fibonacci number. Printf the Fibonacci number is Fibonacci absolutely the seven, the zero, the six, the third, the zero, the CR, the VOC, well, so, by, here, here, zero, bill, review, oh, I have you, oh, I will put you, only you, oh, you go, I will, I will do you, you, I will you, I will you. I don't do you, Function definition: the function Fibonacci is defined to compute the Fibonacci number. Base case is the function first checks if n is 0 or 1. If it is, the function returns 0 or 1 respectively. These are the base cases of the recursion. Recursive case: if n. Example usage of the function is called with a specific value of n, in this case 10, and the result is printed. Performance consideration: while the recursive approach is simple and elegant, it has significant performance drawbacks. Exponential time complexity: the time complexity of this recursive approach is O2n, because each function call generates 2 more calls. Repeated calculations: the same Fibonacci numbers are computed multiple times, leading to inefficiency. Optimizing the Fibonacci sequence calculation to mitigate the performance issues associated with the recursive approach. You can use memoization or an iterative approach. Here's an example of using memoization: Python def Fibonacci memon, memoifn in memo, return memon, 0, return 0, elefmon, return 1, else memon, Fibonacci memon 1, memo Fibonacci memon, memo, Bamo, return memon. Example usage: Natan printf and Fibonacci Pavilion, Palvin, 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 VOL, wow, bear with me, Moeo, Bill, Palvisu, Palvi, VOL, Pavil, Pavilion, while VO, VO, ZOA, 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 while Alweo, I VO, Val, I VO, I VO, 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 while I VO, VO, I will, While a naive recursive implementation is straightforward, it is not efficient for large. By using techniques like memoization or switching to an iterative approach, you can significantly improve performance. This tutorial provides both a basic recursive example and an optimized version, giving you a comprehensive understanding of how to handle the Fibonacci sequence in Python.